All right, ladies and gentlemen. So we're going to look at that formative number two, that one where we predicted the products of three different reactions. So if we take a look at the first one, it says a student in the lab are asked to place 2 grams of aluminum into 100 milliliters of 3.5 molar hydrochloric acid solution. What will they observe? Write the balanced equation. So if we take a look at this one, all right, the big things that we care about are the aluminum and we care about the hydrochloric acid. Okay, we don't really care about those numbers because that's not something we're doing until the next unit. So we're just going to ignore those for now. We have aluminum, which is going to be a solid because it's a metal. So it's a solid in room temperature. All metals are going to be except for mercury. All right. And then we are adding to it hydrochloric acid. So HCl is hydrochloric acid, and it's a solution. So it's an aqueous solution. All right. And all acids are going to be aqueous because none of them are liquids originally. We put them into water. All right. And so we need to figure out our products. And in order to do that, we need to know we need to know our reactivity little list. All right. So if we look over here at our reactivity list, all right, we can see that aluminum is right here and hydrogen is right here. So aluminum and hydrogen, aluminum is higher than hydrogen, which means it can replace hydrogen. So hydrogen is going to get kicked out all by itself. And remember, hydrogen is a gas at room temperature. And hydrogen is also a diatomic, which means it has to be H2. Because remember, we have those 7 diatomics: hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine on our periodic table, plus aluminum and with chlorine. And remember, aluminum has a +3 charge and chlorine has a -1 charge. So we have to balance that charges. So it's AlCl3. And this is going to be an aqueous solution as well because it's still in a liquid. All right. So now the last thing we need to do is balance our equation. So in order to do that, we got to separate our left and our right side. We have aluminum, we have hydrogen, and we have chlorine on both sides. Aluminum, hydrogen, and chlorine on both sides. All right. So we have 1 aluminum, we have 1 hydrogen, 1 chlorine. On this side, we have 1 aluminum, we have 2 hydrogens, we have 3 chlorines on this side. So now we look, the first one that we have to balance is our hydrogen. So we multiply this by 2 and put a 2 here. This 2 goes up front, all right, which means this gets multiplied by 2 as well. But now our chlorine is 2 and 3, which isn't going to work. So we got to multiply this by 3 again to give us a total of 6. And we got to multiply this one by 2 again to give us a total of 6. So this 2 comes in front here, and this 3 changes this one to be 3 times 2. So this becomes a 6 now. All right. That 6 means this got multiplied by 3. So this has a total of 6. This 2 means that our aluminum got multiplied by 2 for a total of 2. Now we got to restart everything. So our aluminums don't match. So on the left side, we got to multiply by 2 to match them. So we put a 2 in front of aluminum. And our hydrogens don't match, so we have to multiply this side by 3 to give us a total of 6. And we need to take this 3 and put it in front of hydrogen. And now we have balanced our equation. All right, if you have questions on how we did that, just let me know. Email, send a Canvas message, ask on Monday. All right, whatever you need. Number 2 is very similar, all right, but this time it says that we're placing 2 grams of aluminum into 100 milliliters of a 5 molar potassium hydroxide solution. All right, so we want to write down that balanced equation again. So the first thing we need is aluminum, and that's a solid, plus potassium hydroxide. And potassium is K, and hydroxide is OH. Potassium has a +1 charge, and hydroxide, OH, has a -1 charge. So those actually balance out. So we only need 1 of each in aqueous solution. We got to figure out this one. And this one's also a single replacement reaction. So we're going to look up at the top again. This time we're going to find aluminum right here and potassium right here. Aluminum is lower than potassium on that chart, which means the reaction's not going to happen, which means you can just write no reaction. And remember, this is shorthand for reaction. All right. Then you just write no reaction, and that's it. You're done. You don't have to do any other work. It makes life really easy. All right. Last but not least, Mrs. Zambelli is trying to determine the compatibility of solutions and mixing 15 milliliters of 3.5 molar solution of sodium carbonate. So that's probably important. All right, we're mixing sodium carbonate with 15 milliliters of 4.0 molar solution of zinc chloride. What are we going to observe? So we got to write out these two reactants. All right, so we have sodium carbonate, and sodium is Na. Carbonate is CO3. Sodium has a +1 charge, and carbonate has a -2 charge. So it's going to be Na2 CO3. Oh, yours says chromate. I know it does. My bad. I changed this after the fact. Sorry, but yours does say chromate. I know that. Yours says chromate, not carbonate. Sorry, guys. I realized after we did the formative that chromate wasn't on your solubility chart and carbonate was. So I switched it later, but yours does say, in fact, chromate. So we have sodium chromate, which is soluble. It's an aqueous solution. I told you guys that on the day of the formative, plus our zinc chloride. So zinc chloride is Zn with a +2 charge and Cl with a -1. So it's ZnCl2, and it's also an aqueous solution. All right, when we react those together, it's a double replacement because we have two compounds, so the metals are going to switch spots. So the sodium and the zinc are switching spots. The easier one to write is going to be sodium chloride, so Na and Cl. Remember, we bring over the subscripts, we bring over the charges and balance out those charges. So sodium has a +1 charge and chlorine has a -1 charge. So it's going to be NaCl. And it's aqueous because it's just salt. So salt is always able to dissolve in water, but we can check that solubility chart as well to see that. All right. Plus, we have zinc chromate. So zinc has a +2 charge, chromate has a -2 charge. So those two balance out to be ZnCrO4. And I told you guys, if you guys remember way back when, that sodium and potassium are soluble with chromate, but then I told you on that formative that other things were not, just because this one is not soluble. So it's insoluble, which means it's going to turn into a solid, which means our reaction does in fact happen. All right, so now we have to balance our equation because that reaction did in fact occur. Right. So if we separate our left side from our right side and we write out our four parts, so NaCrO4, Zn and Cl, NaCrO4, Zn and Cl. All right. On our reactant side, we have two sodiums, we have one chromate, we have one zinc, and we have two chlorines. On our product side, we only have one of everything. So the first thing we need to do is balance those sodiums. Sodium, we multiply by 2 to give ourselves 2, and this 2 goes in front of NaCl. All right, that means it goes to not only sodium, but to chlorine. It's multiplied by 2. All right, and then if we look, we just finished balancing our equation. That is it. That's all we needed to do. If you guys have any questions, just let me know. Otherwise, have a wonderful rest of your day.